So welcome to completing manual tank movement. In this video we will be doing exactly what we say on the tin, which is just finishing off the manual tank movement so that using the left stick alone now I can fly-by-wire control my tank forward, backwards, left and right. So I'll see you in there. Okay guys, so we're halfway through getting this tank movement component sorted. There are other things we could be doing right now, like sorting out the tank aiming component and bringing it in, but look, let's get this finished. We haven't finished the movement component. So we can go back and forth, but we can't go left and right. So let's sort that out. I'm not going to challenge you to do that because it's actually relatively simple. We have a option here to intend move forward. We no longer need that log entry there. I think I'll just ditch the log entry actually now. I'll be brave. We have a to-do about preventing double speed due to dual control use. I actually think we have that in two places. Let's look at the task list. Yeah, we do. Clamp actual throttle value. Yeah, so that's actually the same thing. So I'll get rid of it there. What we're saying is that we don't want two inputs from the shoulder buttons, etc., to double up. Anyway, so we don't need that in two places. We'll leave that one in there. What I want to do now is an intend rotate clockwise. That's what we want to do next. So I'm going to copy that because it's relatively similar. Intend rotate, or intend turn right. How's that? Yeah, let's go intend turn right. Now, what is the issue here? We still want to prevent double speed rotation, but what is the issue with what we're doing with the tracks? Well, it's actually pretty simple. Look, we are just setting the left track to, well, if we're going to turn right, the left track's going to go forward and the right track's going to go backwards. So if we are fully, with full throw, turning right, then this is what happens. And if you're partially turning right, then you'll have both of these tracks set to partial throttle. So that's pretty easy, isn't it? Let's see if it works. Of course, I'm just going to pop into the public sector, the intend turn right. Declaration. It's going to be part of the input part. And semicolon. I think we're good to go. Oh, sorry, Unreal doesn't like. Let me just try this one more time. I never remember. Are you allowed to put a semicolon on the end of a U function? I should make an effort to remember. Let's see. Because if you can, it's better because Visual Studio doesn't keep indenting accidentally for you. But I think it's going to complain, unfortunately. Yeah, it depends on every... let's just check it. Is this it's complaining line 25? Yep, sorry. You're not allowed to put semicolons on the end of the U function annotation. It's a shame because it forces on Visual Studio to misbehave. All right, while that's compiling, let me show you something else useful. I often open, say, the tank blueprint. It opens in another window, but it doesn't always open in another tab like this. It did in this case because I had just opened it. But if you want to be sure that things always open in a new tab, you can go to Edit and Editor Preferences. And then if you look under your Editor Preferences, you've got, under User Interface, Asset Editor Open Location, we want to open that in the main window. If you want to do that, that's great. That's that setting there. And what that'll mean, if you open a new asset like this barrel, it'll just open right up here in this main window. I prefer that. If you do, well, then bully for you. There's an option. Okay, so where are we? We're going to test this. The compilation has happened. I saw that happen. That's fine. I think we can pretty much... Do we need to do anything in the blueprint? I better compile the blueprint. Okay, we can pretty much just play. And let's try left and right. Nothing on the left and right at the moment because I haven't bound input. So you go to the settings, the project settings, input, and we need to make ourselves an axis, which is going to be turn right. And then we're going to assign that to the gamepad left thumbstick x-axis. Now it only needs a turn right and a move forward because, of course, if you go negative in either of these, then they obviously give the negative value, so you don't need move backwards or turn left. But I'm giving them a very specific name because it makes clear what a positive value is. A positive value is turning right. All right, so to the tank blueprint, Batman. In the input setup, we have this intend move forward thing here. Well, it's going to be very, very much like that, right? We're going to go and find the turn right event. We're going to drag it off to intend move forward on the tank movement component. It very kindly finds the tank movement component. We could share that reference between the two parts of the blueprint like that. So there's just a single tank movement component. It's kind of personal choice whether you do that or don't do that. Compile it up. I'm going to save all. And let's see if we can turn on the spot now. I'm using the left stick on the controller. No, not at all. Okay, so what's going wrong? Let's go and have a look at the code. Let's make sure that we actually are getting this intend turn right being called. So let's put our UE log back in. In fact, if you've deleted some code and you wish you hadn't, what you can do is you can go to your source control. You can look at your unstaged changes, go find the thing that you deleted the code in, which in my case is the tank movement component CPP. Go find your log file, which was there, your log entry, and you can paste it straight back in from there, which is pretty handy. Okay, so we're going to UE log intend turn right at throw. Let's just log that out and make sure that that's happening. Meanwhile, I'm just going to check the other prerequisites that we have. Turn right is the string. I'm going to check that's right. When we look at the blueprint, gamepad left thumbstick x-axis is correct. Look at the tank blueprint. Input axis turn right. Yep, that's right. It looks very different to this one. That's just because the word right is much shorter than forward. And it should, look, I'm calling the wrong thing. I'm calling intend move forward. I need to be intend turn right. And that is the problem. So I'm kind of debugging it on two levels at the same time. So that's just saving me time. I have written a log statement over in the C++ to help me diagnose this, but I suspect it's just going to work now anyway. There you go. It works now. And if we look in the console, we do see these intend turn rights coming in. In fact, if I clear the log and play again, we'll find you can see those, and you can see the amount of throw and how it's working. So we can not only turn left and right, but we can move around. So we actually finally have motion. Now that bug there is the tank either self-colliding or hitting an imperfection in the terrain. So we'll need to find a solution to that later, but we'll live with that for right now, because what is good is that we can move this aim point around, and we can move the tank. I'm actually finding now with these controls I don't like my y-axis being that way round. I prefer my y-axis inverted. And of course that's incredibly easy because you go to aim elevation and you just go to -1 on the gamepad right thumbstick y-axis. And that is the sort of thing that would be set through an invert y-axis control for the player. And now that feels a lot better for me. And I feel like I can move around and I can aim at these tanks. And I could even bind a fire key, of course, to, say, the right trigger or to the A button. I think I'll make it the A button, so let's do that now. Action mapping, fire, we've already got it. And this is where our work on the project starts to compound, because we've already got places for everything, and it's starting to make a lot more sense. So do I have an A button here? I think it's gamepad face button bottom. Let's try that, face button bottom. Reminds me of the Minions films. Bottom, hee. Okay, that's it. That's right. So the face button bottom, hee, is the A there. So that gives me what I want. Fantastic. So that is a lot of the movement component now done. We can move, and the other tanks, of course, aren't moving, apart from the one that's sliding down the hill due to friction. And of course, the reason they're not moving is because they are not, well, there's a few reasons actually. There's no nav mesh on the terrain, and also we have not intercepted the code at the right place in order to find out if, even if there was a nav mesh, and if these AI tanks were going to be trying to navigate to us. We haven't set any of that up, so that's obviously why they're not moving. So you'll find out what a nav mesh is and how we get into this AI stuff a little bit later. I just want, well, in the next video, I just want to take a quick look at the tank movement component header file with you while we're working on it and make sure that it all makes sense and that things are in the right places. So just taking a look at this, it looks fine. We need an initialize. We need a public initializer because we're going to call it from blueprint. And then intend move forward, intend turn right is very simple. That's consistent with the responsibility of the tank. It's responsible for, not from, driving the tank tracks, and then we just have a couple of private references to our tracks. Why do we need those references? Because we use them in several different methods across the class. So it all looks very clean and simple to me. The only thing I would say is in the initialize method, we don't need to be checking pointers because there's no need. If we passed in a null with left track to set or right track to set, well, then these things will just get set to null, and they were null before. So it's really not doing anything, that code. But what we can do is move it from here down to the intend move forward method, because there you do want to make sure that the left track, not the left track to set, and the right track, not the right track to set, exist before you try doing anything with them. And actually it's the same deal there with the intend turn right. You want to be protecting your pointers. So I'm going to get rid of the log entry, have my pointers protected here, leave my notes about doubling up on the controls, do a final compile of this to make sure it works, and then we'll look forward to looking at the artificial intelligence and how that's going to work. That's going to be a lot of fun. So just quick, wait for the compile. play it forward, backwards, rotate, rotate, barrel moves, all looks good. Final thing to do, of course, is to play it from the main menu, because you can have problems with race conditions and the order in which things are constructed. So forward, backwards, left, right, aim and fire, all works. Great news. So well done getting that far. I will leave for you the changes that I've made to the code. I'll just quickly flick through them now, so you can pause the video if you need to. So in the tank movement component C++, we have removed some useless pointer protection on the initialize. We have added pointer protection to the intend move forward, and then we have done the intend turn right, basically by just setting one of the throttles backwards, very, very similar to the forward. Then what else have we done? We have not much else, to be honest. That is mainly it. We've then, of course, wired everything up in the tank blueprint like so down the bottom here. So your challenge, if you haven't already followed me along in this video, is to get this far, get your tank moving left, right, up, down, get your control systems how you want them, and I will see you in the next video.